Okay, dear students, let us see what is there in this question. A standing wave is formed on a string. P and Q are adjacent antinodes on the wave. So P and Q are adjacent antinodes on a wave. Three statements are made by a student. Number one, the distance between P and Q is half a wavelength. Number two, P and Q have a phase difference of pi radians. Number three, energy is transferred between the point P and Q. Which statements are correct? So, my dear students, let us try to understand this thing. Like P is an antinode and Q is an antinode. So, one of the permissible cases will be like there is a string which is fixed at both ends, and there is a node at the center also. So there is this antinode and there is this antinode. It's like this. Okay, so this will become the another wave, like the other time period, and this will become the other half. Okay, so this is how the standing wave is created. I've just taken a case. It is not mentioned here that the string is fixed at both ends and it is the second harmonic. They are not talking about that, but I've just assumed it. That let us say this point is an antinode, so this point is P, and this point is another antinode, the point is Q. So these are adjacent antinodes on the wave. Three statements are made by the student. The distance between P and Q is half the wavelength. Well, exactly, isn't it? Like because from this point to this point, it is the complete wavelength, and this to this, it is the lambda by 2. So the first statement is absolutely correct. Point number two, P and Q have a phase difference of pi radians. So this P point is moving upwards and the Q point is going downwards. And as the property of the standing waves, that if the 2 points are in the adjacent segments, the phase difference will always be pi. And if the two particles are in the same segment, the phase difference is always zero, and there is no other option of the phase difference. Like either it will be zero or it will be pi. So there's no confusion here. P and Q are the two different points in different segments, and hence the phase difference is definitely going to be pi. There's no doubt about it. Like when P goes up, the Q goes down. Third point is that energy is transferred between P and Q. Now, this is also one of the characteristics of this standing wave. And what is it? That the energy is not transferred beyond the node. Like for example, this is the node, so energy of this segment, it is contained in this segment. It cannot move to the other segment, and the energy contained in this segment will always be restricted within the same segment. It will just keep on moving up and down, but the segment, the energy will not be transferred because it's not a traveling wave, it's standing wave. Standing wave means it's not transferring any energy. Now, why is that the energy is not transferred and we still call it a wave? Because standing waves comes into formation when two waves having the same wavelength, having the same frequency, but they're traveling in the opposite direction, they superpose each other. So when they superpose each other, the resultant wave is the standing wave. Now, as I have already told you, standing wave is the resultant of the two waves which are traveling in the opposite direction. It means one wave is trying to transfer energy from left to right, and another wave is trying to transfer energy from right to left. So overall, there is no energy transfer. And that is why this point is definitely wrong. So our answer will be 1 and 2. So this is how we explain this question, my dear students. Let us see what is the answer given in the mark scheme. And yes, the answer is given as A. So this is the explanation for this. My dear students, if you have any doubt, please mention that in the comment section. This is Professor Varun. Please subscribe to the YouTube channel. All the best.